All right, good day, everyone. I know that we've been waiting for this particular live class. It was meant to kick off by 12:30, but of course, you know, GMAETS 41 is always very busy attending to a lot of academic requirements of different students and different levels, okay? Here, together with me and my friends, my team and students of GMAETS 41 Special Science College, we are set to carry out this experiment. This setup you're seeing is experiment M6 of Physics 107 that is to be carried out by Unit 6 students, 100 level. So this experiment M6, according to the instruction we have here, the title is Oscillating Loaded Cantilever 2. We actually have Oscillating Loaded Cantilever 1. On this channel, we've done works on it already. Okay, the principle from there also applies a bit to this particular one anyway, but just take note that this is Oscillating Loaded Cantilever 2. What is our aim? Our aim is to determine the relationship between the period of oscillation of an oscillating cantilever and the weight of the said cantilever. Cantilever. Look at this is what we refer to as cantilever. This is a ruler. It's a 100-centimeter ruler. Are you following, right? Clamped at this point. I'll tell you the point we clamped it and why we used that point according to the instruction. Are you following, right? The cantilever will be loaded. With this setup, it is not loaded. Here you notice that this end is free. There is nothing attached to it. Following the instruction, we are going to be placing masses. Are you following, right? We are going to be attaching masses to this end. And of course, up to about 300 grams, which is 0.3 kilogram, according to the instruction. Now, I have told you what we're about to do. The experimental apparatus, you can see some of them. The meter rule, the G clamp or clamp. We have our masses. Think that's sufficient, the apparatus we need for this experiment. Now we are going to go straight to the instruction so that we can demonstrate this experiment and generate values for you, dear students. However, like I've always advised students, I don't like it that you just copy values unnecessarily. Understand this practical for what it is. You can actually do it even in the laboratory. The only thing I'm going to do is, by the time we run 2, 3 of the experiment, we are going to check the range of the values we are getting for the time it will take for 10 oscillation according to the instruction. And then perhaps with that range of value, we can now try to that students in the laboratory can use that range and then vary their values so as not to run the experiment till the end. However, this is dependent on time. If you have enough time, come on, get to the end of it. If you don't have enough time, by the time you do up to 3 of the experiment, check the range. And you can use it to manipulate 1 or 2 things. The wand, fear manipulation, I always say that. So please, let's get into business. We have the instruction here. Are you following, right? The first instruction is fasten one of the meter rule to the table using the clamp provided with 7/10 length hanging off the table. We are to fasten one of the meter rule. Look at it on the table. This is table. I say you can see reflections. I know you are wondering which table is reflecting like this. Don't worry, this is GMAETS 41, right? Yes. Okay, so we are to fasten one of the meter rule. Look at the meter rule on the table, and according to the instruction, 7/10 of its length is meant to be hanging off the table. What does it mean? If you evaluate 7/10 of the length of this meter rule is 100 centimeter. 7/10 times 100 is going to give you 70 centimeters. Is that not so? Yes. So what it means is that the free end of this ruler that is going to be hanging off the table is meant to be how many cm? 70. Do you understand that? And how do we achieve that? From this end that entered the table to a point 30 centimeter, you can come and see that, right? To this point 30 centimeter. So from the total length of the ruler, you have taken off 30 centimeter. So 70 is now hanging freely off the table. So according to instruction number 1, we have done that. Are you following, right? Yes. So you clamp at 30 in order to leave 70 off the table. Now the second instruction said, using the second ruler. Using the second ruler. This is the second ruler. I'm using this plastic ruler. Measure a fixed distance down of 35 centimeter. Measure a fixed distance down. In the diagram, you see, for any physics experiment, usually you are given a diagram. You can see the diagram here. We are to use this second meter rule, then measure a distance down 35 centimeter according to the instruction. 35 centimeter according to the instruction. But hey, I want to say something, please. This experiment, why it is generally applicable to any student in any part of the world, we are looking at Unit students because this week they are working on this experiment. And based on the instruction given to them, this using the second ruler, measure a fixed distance down of 35 centimeter. The students were actually told to measure 15 centimeter down instead. Are you getting me right? Not 35 anymore. So what does it mean? We shall place from this end of the ruler, we are going to do something like this. We place this ruler down this way, and then we will measure. We depress this ruler down 15 centimeter. 15 centimeter. So it's just like somebody will hold this ruler from this point. Maybe someone can come and help out. You hold this ruler here. So you hold this straight downward. Straight down. Don't bend the ruler. Straight downward from here. Okay? Then we are going to press. I'll advise you take it inside a bit. So when I'm pressing it down to 15 cm. Are you following, right? This thing is up. You shouldn't do that. Make sure you place your hand as much as possible. Are you following, right? That way. Even when I'm pressing this down, don't move this ruler. Still try to hold it that way. Are you following, right? So we are meant to depress it good. We are meant to depress. Don't move your hand. Let your hand be fixed this way. I'm meant to depress this meter rule down 15 cm. You can see that it is at 15 centimeter now, right? I hope you are following this analysis. So take off the ruler now. Holding this thing, this is 15 centimeter down. Are you following, right? Yes. So we are going to leave the meter rule and it will oscillate. 10 oscillation. This level I depressed it is half a circle. If I leave it, it will move up. Coming up, I'll count 1. You know, this is oscillatory motion. So toe and fro, toe and fro. So this is toe now, 15 centimeter. If I leave it, it will go up, fro. So that will be 1. It will come down, up. That will be 2. Down, up. That will be 3. Are you following, right? Yes. For the first experiment, we are not asked to place any mass here. Please let me get. You see, in the first instruction, you are not meant to place any mass on this free end. You are not to do that. In fact, the instruction number 3 said, pull down. I don't know if this can show, you know, but I believe that those in Unizig, they already have the instruction. Others that are connected and following this analysis, you can listen. Instruction number 3 said, pull down the ruler down to the marked length, which is 15 centimeter. We just did. Pull down the ruler. I've pulled it. We are still going to do it again. That's instruction number 3. Then instruction number 4, trying to say this is not showing well. It's not. So no problem. Let me be reading. Please follow up. Instruction number 4 says, fasten the mass to the ruler using a minimal amount of tape. Now, for this first experiment, we are actually not supposed to fasten any mass. We are not supposed to, and I'm going to explain why. In the table of value given, the first mass is 0, 0, 0. That first mass that is 0, 0, 0. Hold on, let me try to see if this can show this table of value. Please take a look. This mass column. This mass column. You notice that the first mass, is 0.00. I'm trying to place this so it will show all right. It's showing now. The second mass is 0.05. The third mass is 0.1. The next one 0.15, 0.2 down to 0.3. These masses are in kilogram. Our masses are in gram. Okay, so if you hear 0.5 kilogram, 0.05 kilogram is actually 50 gram. Are you getting me right? Because to convert, that is just going to be in the table. We have the equivalent masses in gram. For the first experiment, you are not required to place any mass. You are not required to place any mass. Look at the column there. Look at the column. Don't mind this device. For the first experiment, under the mass column, it is 0.000. So you are not actually required to place any mass. You are not placing any mass on this for the first experiment. But from the experimental instruction, there was a variation in that. I don't know. I think they have to rework on that instruction. For the first experiment, where you depress this thing 15 cm, no mass should be placed here. It's from the second experiment that you add a mass of 50 grams and then continue increasing by 50-50. That is the instruction. But I'll advise those of you that are in Unizik to listen to what your lab technologist will say. If in the first experiment you are asked to place the mass of 50 centimeters, fine. But according to the instruction in the manual given for the first experiment, from the table of value, you are not meant to place any mass for the first experiment because the mass for the first experiment is given as 0.00. Once again, bring this meter rule, please. Good. Make sure this thing is straight. I'm not saying it's straight. Bring it to this level. Good. I'm now going to depress this down to 15 cm. You see, you place this thing at the end. Let it be somewhere there. Good. So we go again. So once it gets to 15 centimeter, you can see it. I think it's at 15 now, right? Yes. Good. Take it off. So this is 15 centimeter. We will get our stopwatch ready. We will get our stopwatch ready. This is my stopwatch. There is reflection somehow. I have my stopwatch here in this device. You can see that. I try to set so you can see it. So in the lab, you have to get your stopwatch ready. Once you are leaving this and counting, you set up this stopwatch. You start it and then start counting for 10 oscillation. That is what the instructions say you should do. RS in 20, you say that it's changed to 15 centimeter. Yes, I have that instruction. That's why we are depressing 15 centimeter. So we go. Watch. Once I release this meter rule, it goes up. That is 1, come down up, 2, come down up, 3, 4, 5. Immediately I'm releasing this, I would put on the stopwatch. Are you getting me right? Yes, sir. So let us go. Are we ready? Yes. Watch as I'm doing this simultaneously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this gave there about 5 seconds. 5 seconds. We are still going to repeat this again. Let's measure it again. See, this was so fast. Is that not so? And it's expected. Let's repeat it again. Let's repeat it again. So I'm depressing. That ruler is bent now. Aren't you seeing it? You keep it straight. So you don't even need to hold this. Don't apply any pressure from under and don't press it down. Okay, let it be free, very easy like that, okay? Good. So I'm depressing this to 15. Stopwatch. I'll take it to 00 and then we are set. Remove the ruler. That's fast. Are you ready? Yes. Are you ready? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This gave 4 seconds. This gave 4 seconds. You can see the first was 5 seconds. The second one was 4 seconds. You can see the 4. I'm trying to see that this thing shows. Look at it. 4 seconds. Okay? Good. So that is the first experiment. That is the first experiment. That is the first experiment. All we have to do is to now record. Are you following, right? We'll record. Now, according to the instruction, the first column is mass. Mass in kilogram. Mass in kilogram. Then the second thing is to measure the time for 10 oscillation. Are you following, right? The table was provided. So it's just for us now to follow up and fill up the table. Okay? So for those in Unizik, you have the table of value. I've actually tried showing it as well too, so that others can follow through. Now, the second column is the time for 10 oscillation. You can see that, right? Yes. Then you're also asked to do it for T2. You are repeating the same thing for T3. you have to measure the time for 10 oscillation once, twice, and what? 3 times. We tried to do it 2 times, is that not so? The first one was 5 seconds. The second one was what? 4 seconds. Now, if you have to do it the third time, you would see that the time will still be within. Are you following, right? Yes. The time will still be within. So I usually advise students, once you do it for the first time, you don't really need to punish yourself going the second, the third time. Use your sense. Use your sense. The first one is 5 seconds. So perhaps the second one will be within 4 point something or 4 or even 5 point something. The reason for that is for you to maximize the use of your time. Going to do it 10 oscillation, you find out the time for 10 oscillation the first time, repeating it again, doing it again, it might take your time. If you have the time in the lab, fine, do it. But if you don't have, measure the time for 10 oscillation once. Use that time for 10 oscillation to decide what T2 and T3 could be. Now, after you measure T1, T2, T3, you have to take T average. Of course, T average is for you to add T1 plus T2 plus T3 and divide by what? 3. It remains average. Are you getting me right? After that, you have to evaluate the average uncertainty. Average uncertainty. The average uncertainty, what you are expected to do, the formula was given there. The average uncertainty is 0.01 divided by T1 plus 0.01 divided by T2 plus 0.01 divided by T3. That is the average uncertainty. I'm trying to make up the table, how the table will look like and show. The next column is period. Period. You have to get a period. The next column is to get square of the period. Square of the period. I think I'm going to repeat this. Let me turn this sheet of paper this way. So we have the mass column. The mass column is in kilogram. The next one is T1 in second. The next one is T2 in second. We have T3 in seconds. We have T average, which is the third column again in second. We have the average uncertainty. Average uncertainty. I'm sorry that I've not written out this table before. Average uncertainty. The formula for the average uncertainty is 0.01 divided by T1 plus 0.02, plus 0.01 divided by T2 plus 0.01 divided by T3. That's the average uncertainty. You can see that here, is that not so? Yes. Now, you are multiplying this by T average. The average uncertainty is meant, that's 0.01 over T1 plus 0.01 over T2 plus 0.01 over T3 is meant to be multiplied by what? T average. Yeah. And then the next, you have your period capital T in second. The next column, you have your square of period. Square of period is square second. And the last column is your Young modulus. Your Young modulus column, you're required to evaluate it using the formula 16 square pi m times L divided by BD cube and then times T square. The unit is Pascal. The unit is Pascal because Young modulus is dimensionally equal to pressure. Young modulus is dimensionally equal to pressure because it uses the same unit as pressure. Stress over, I think that is stress over strain. So this is what the table, the column will look like. The first mass, T3, T average, then average uncertainty, which you are seeing 0.01 over T1 plus 0.01 over T2 plus 0.01 over T3, then multiply by T average. The next column is the period, capital T. The next is square of the period. The next is your Young modulus. This is the formula of the Young modulus. This PA is the unit of the Young modulus, Pascal. Pascal. So you have this table. Now, the mass values are given to you. The first case of the experiment, which we've just done, the mass is meant to be 0.00, which means there is no mass there. You are not meant to attach any mass here in this case. Now, the second case, we have a mass of 50 grams, which is 0.050. The next one is mass of 100 grams, which is 0.10. The next one is mass of 150 grams, which is 0.15. The next one is mass of 200. In the instruction of the experiment, you are meant to be increasing the mass by 50. Are you getting me right? So the next one, if you increase 150 by 50, you get 200. Right? 200 gram divided by 1000 is 0.2 kilogram. The next one is 0.25, which is 250 kilogram. And then the last one is 0.300. So these are the masses. The masses are given in the instruction already. For the first experiment, you are not attaching any mass. You are not adding any mass to this end. And that is what we have done. We got T1 to be 5 seconds. And we got T2 to be 4 seconds in that case. Is that not so? Now with this, I don't need to do T3. I don't need to. On my own, I can decide to fix T3 to be 5 seconds or even the 4 second. Or maybe a value between 4 and 5. The choice is mine. Once you get this T1, you should use your own intuition. Use your sense to determine what T2 and T3 should be. The value should not be far from T1. If T1 is 5 seconds, T2 will be, let's say, plus minus 0.5 or 1. Are you following right? That is to say, add 1 to the, subtract 1 from this, or perhaps subtract 0.5 or add 0.5 to this. That's just the whole idea. So for this, I am going to record T3 perhaps to be equal to, let me say, 5.5. Let me say 5.5 is my choice. Is it 5.5 or let me make it 4.5 rather? 4.5 is a value between 5 and 4. So we are done with the first experiment. To get T average, all you have to do is to add 5 plus 4 plus 4.5, and then you divide by 3. Everything from here now is calculator work. And I always advise students, finish up the experiment first. Are you getting me right? Before you do any other calculator work. Values you measure directly from the experiment. Finish it first before you start doing any calculator work. From T average to average uncertainty to period to square of period to Young modulus, all of these are calculator stuff. They are not values you read from here. Are you getting me right? The only value you read from your experimental work is the time for 10 oscillation. Of course, remember that your period has a formula. Period is the time taken to cover the number of oscillation. Are you following? To cover one oscillation. So this is equal to the time taken, which is going to be T average divided by 10 oscillation. That is how you obtain your what? Your period. All right, we are preparing for the second experiment. According to the instruction, in the second experiment, you are required to increase the mass on this meter rule by 50. Let us take a look at it. Let's take a look. Remember, in physics experiments, you always have, in fact, experiment generally, both chemistry, you have a guiding principle, a guiding instruction. So after this first one, where there is no mass here, instruction number 5, instruction number 4 said, fasten the mass to the ruler using a minimal amount of tape. Fasten the mass to the ruler using a minimal amount of tape. That's mass we are going to fix now. If you look at the mass column, we can take a look at it. The mass column in kilogram is 0.05 kilogram. 0.05 kilogram. 0.05 kilogram in gram is 50 gram. Are you getting me right? Yes. So if I give you a value in kilogram, to convert to gram, you multiply that kilogram by 1,000. Yes. And to change gram to kilogram, you divide by 1,000. 0.05 kilogram. If you multiply by 1,000, it will give you 50 what? Grams. Therefore, for the next experiment, I am going to get a 50 gram mass. This is 50 gram mass. This is 50 gram mass. You can see it, 50 gram. So we shall attach it here, then use a minimal tape. I don't have a tape here with me. I usually use rope to fasten the mass. Are you following right? Yes. So I'm going to tie this mass. I'm going to tie this mass to this end. I'm going to tie it to this end. I'll fasten this mass of 50 gram. If you are given a tape, fine, use your tape. If you are given a tape, you use your what? Tape. I have rope here. So I'm going to use my rope. I'm going to use my rope. So I'm trying to fasten it. And let me tell you, dear friends, something. Whatever you are doing now is just a repetition of the first procedure. Whatever you are doing now is a repetition of the first what? Procedure. Remember, with this mass here, the next thing, according to the instructions, said you should repeat step something and something. Are you following, right?
Yes.
In fact, look at how it was presented. Repeat steps I, IV, and V additional times to ensure consistency for 10 oscillation. That issue of T1, T2, and T3. Are you getting me?
Yes.
After that, instruction number 7, where we are now, said you should increase the ruler's mass by adding 50-gram weights evenly. We have added the first 50-gram weight. So we are on instruction number 7, VII. That is where we are now. We have fastened the 50-gram mass. Now bring this ruler, the second ruler, from here. Are you following, right? Make sure the ruler is straight vertically. Now I am going to depress this down to how many centimeter? 15 centimeter. Get me my stopwatch from there. Get my stopwatch. Now put it again. Let me measure. 15 centimeter. I'm getting my stopwatch ready. You see, I will take it from the value we read earlier to 0. So it's there at 0 now. I will depress this to the 15 centimeter mark of the meter rule. You can take it off. It's there now. Is that not so?
Yes.
Now, watch. Once I release, I will put on the stopwatch and I'll be counting. Remember, once it goes up 1, come down 2, up, oh no, go up 1, come down, go up 2, come down, go up 3. Are you getting me right?
Yes.
Are we ready?
Yes.
So as I release, I would start the stopwatch. We go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once it is 10, you press the stopwatch. Now this gave 5.27 seconds. 5.27 seconds. Let me try to show it. 5.27. Then we can see it now. 7. We have to repeat it. That is T1. Yes. T1 is 5.27. So I am going to record. I'm recording it here. 5.27. Let's see. We are going to repeat for T2 again. Are you following, right? Yes. So with this mass this way, place the ruler. Let's depress. Let's depress to 15 centimeter. It's there now. Take it up. Take it off. I am resetting this. I'm resetting this. You can see now it's reading 0, 0. Are you getting me right?
Yes.
Once I release, it goes up 1, come down, go up 2, come down, go up 3. Are you ready?
Yes.
Are you ready?
Yes.
So here we go. As I release, I will start the stopwatch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once it is 10, you have to stop. Are you getting me right? Now look at what we got. 5.79. 5.79. So I will record it. 5.79. Remember, we have obtained T1 and T2.
Yes.
You can do T3 if you want, but I don't want. I will use the knowledge of the fact that T1 is 5.27, T2 is 5.79. I will just simply write 5 point something between them. Are you getting me right?
Yes.
Choice is mine. But remember, like I've always said, if you have enough time, complete it. If you don't have, can do that manipulation. Use your sense, right?
Yes.
So I am going to write 5.35. 5.35. Is that okay?
Yes.
As the time. Now we are going to move on to the next experiment. We are repeating the same thing all through now. The only thing we are going to be changing is this mass. We'll be increasing the mass by 50 grams.
Right.
This mass is mass of what? 50. So for the next experiment, we shall increase this by 50. If you increase this by 50, what mass will you get? 100 gram mass. So let me remove this mass. I want to lose it off. I'll lose it off. Then I can add another 50 to this. But I don't want to do that. I have 100-gram mass. This is GMAETS 41. We've got all these things available. Yes. This is 100-gram mass. Let's see. You can see it written on it, 100-gram mass. So I am going to place this, the 100-gram mass. I'll place it here and then fasten it. If you have your tape, you fasten with your tape. For me, I have rope. I am going to tie it up. I'm going to tie it. Good. So let me tie this. Let me tie this. The second tying, I will loop it so that I can be able to lose it. All right, we are there. You notice that as you hang any mass, as you're increasing the mass, the depression is increasing, it's going down. Yes. It's going down on its own. All right. Let me adjust the camera a bit so we can see the mass. Now, get the ruler, the second ruler, place it. I'm going to depress this thing down 15 centimeters. Make sure the ruler is straight, vertically straight. So we are going down, depressing 15 cm. You are bending this. Don't bend it. That's all. Hold this thing straight this way. Are you following? And then let me go down. It's there at 15 cm now. Yes. Get me the stopwatch. I hope you guys are following. Once you connect to this class, please like what is happening here. Especially to those in Unisic, your experiment. Sadly, there is no way you can manipulate this particular experiment because there are two unknowns you are trying to verify in this experiment. All right? The young modulus and then the period. So there is no manipulative formula that is generated that can be generated here. You just have to do this experiment, like I said, up to like 2, 3, or let's say 3 of them, and then you can use the range to determine what others can give to you. You are focusing on measuring the time for 10 oscillation. Are we ready? Yes. Now I've reset this thing back to 0. Take a look at my stopwatch, trying to have it reflect. Good, 0 there, you can see that. So once I release this, immediately I'm releasing and putting on the stopwatch. And remember the way you count. If it goes up 1, come down, go up 2, come down, go up 3. Are you ready? Yes. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this 10 gave us 7.67. Let it show up 7.67. Trying to have you guys, see the time. Come up 7.67 seconds. So we're going to record it as our 100-gram mass. 100-gram mass is equivalent to 0.1 kilogram. Are you following, right? So T there is 7.67. 7.67. 7.67. Then we now have our T2. Let's repeat this for T2. Let's repeat this for T2. Let's repeat this for T2. The person calling me, I hope the person could just be patient. Let me finish up this. Excuse me, please. Hello, madam. Good afternoon. I am fine. Please, can I call you back in a moment? I'm conducting an experiment right now, please. And I am live on YouTube, okay? Please. All right. So, let's go again. The stopwatch has been reset back to 0. I'm going to depress this to 15 cm. It's there at 15 now. Yes. Can take the ruler away. So are we ready? Yes. Ready. You know how we count already? Yes. As you leave, it goes up 1, come down, go up 2, come down, go up 3. Because the coming down and the going up makes one complete oscillation or cycle or revolution. Are we together? Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 here, this is 7.45. 7.45. That's our T2. So So I'll come to T2 and record 7.445. If we work on, so on your own, you can decide to, fix a value for T3 without repeating it. And I'm going to do it. We have 7.67, we have 7.45. In fact, on your own, you can even decide to take the average from there somehow to get T3. Add T1 plus T2, divide by 2 to get a value you can use for T3. All these things now are certain manipulations you may decide to use. But even when you get T1, if you get T1, you might even decide not to repeat T2. Are you getting me right?
Yes.
That T1 value, fix things within it. Like I said, plus minus 0.5 is sufficient for what I am seeing here in the experiment. So for this T3, for the mass of 100 gram, which is 0.1 kilogram, I am going to fix 7.50. I'm going to fix 7.50. I've done it. That is my choice. It is still accurate within experimental error. From what we have done so far tells us that the time is within that 7 point something.
Yes.
Excuse me, something is trying to, an ant is moving. Now we are going to move on to the next experiment. Look at the values we are generating, please, dear friends. Look at the values we are generating. Look at, we have obtained the value for when there was no mass attached. We have a mass of 50 gram, which is 0.5 kilogram. When we have a mass of 100 gram, which is 0.1 kilogram. We're now going to work for 150. You can see the value of T1, T2, T3. Like I said, these ones, you evaluate everything from here down to the end. We finished this concept of T1, T2, and the rest. I would like us to do that of 150. Are you getting me?
Yes.
With what we have done so far, the students can work on the mass of 200, mass of 250, and 300 gram, respectively, which is equal to 0.2 kilogram, 0.25 kilogram, and 0.3 kilogram. Once I am done with this, we shall evaluate T average. At least we are going to find T average for the first value, average uncertainty for the first, period for the first, T square for the first, Young modulus for the first. And I also do for the third one, at least, so that you friends will know how to evaluate all these other columns. Please, we are moving to a mass of 100 and what? 50. Already we have a mass of what here? 100. So to get a mass of 150, which is 0.15 kilogram, what would we do? We are going to add 50. This is mass of 50 gram. This is mass of 50 gram. Okay, don't mind that it's rust a bit. This one is better. You can see it. Okay, you have one there. Mass of 50 gram. So I'm going to attach it to this guy. Let me attach it to that of 100. Hold this for me. So I have that of 100. And then we are going to tie. Hold this as I tie. Good. If you have a tape, it is better and faster. Are you following, right?
Yes, sir.
Because all you just have to do is use the tape to mask it. Let me tie this. If you are using rope, it will stress you a bit. Is that okay? Because you have to tie, loose, That process of tying and losing, you are wasting it. You are wasting it. Okay? Now you notice that the depression went down even beyond the former one. Now place your ruler. Place your ruler. Then we shall depress down again. So you friends are seeing how you run this experiment. Okay, are we there? Make sure that this second ruler doesn't bend, right? So I'm going to depress 15 centimeter. Is there now?
Yes.
Remove your ruler. Now let me reset the stopwatch from the original value of 7.45. I'm resetting it to 00. I have reset. You can see it a bit. So we release and start counting. Are we ready?
Yes.
Please pick that paper. Use one of the masks to support it. Okay, so get set. Once I release, I'm going to start the stopwatch automatically and then count. Are we ready?
Yes.
We go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10 gave us 7.79. 7 point what? 79. We have no choice than to record the 7 point what? 79. Good. So there is a pattern that this experiment is taking, and I want you friends to see it. And that is expected from the experimental theory. The time is increasing. The time is increasing. The time it takes to cover the 10 oscillation is increasing as the mass is increasing. Are you getting me?
Yes.
And that makes sense, because if this mass is increasing, the cantilever is going to undergo what we call bending moment. You can see that as you're adding the mass, the cantilever is bending, thereby making it dull. Are you following, right?
Yes.
As if it is sagging. As if it is doing what? Sagging. And that will lead to a delay in oscillation. Are you following, right?
Yes.
Hence, an increase in what?
Time.
The time. Let us repeat this. Let us repeat. Bring the meter rule again, the second meter rule. And then I'm going to depress the 15 cm. Are we ready?
Yes, we are ready.
Okay, so, oh no. Look at this on the 15 centimeter side. Turn the meter rule. Turn the meter rule. So we go 15 cm, taking it down, taking it down. Is there now? Is that not so?
Yes, sir.
All right, we get our stopwatch set. I'm going to reset the stopwatch from 7.79 to 0. You can see that now. So we go. Are we ready?
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 8 point what?
03.
8.03. So we shall record it as T2. 8.03. You see that it is very close to 7.79. Is that not so?
Yes.
Now look at the value we have here. For a mass of 150, we have 7.73, 7.791, and we have 8.03 T. Then T3, you can decide whatever you want to fix there. Let me boost the network a bit. Right. So this is what we've obtained so far. One can continue this experiment. For T3 of 0.150, I can decide to fix a value. The choice is mine. I might fix a value between these. How about I say, but if you are fixing, be guided by what you have above. Remember that the values below are above the ones. The values below, they are greater than the ones above. So if I am to ask you, which value do you think you fix here, considering this and considering the ones you have above?
Let's fix 8.0.
8.07 increases. I hope you know that, right?
Yes.
8.07, the choice is yours. I can decide to use 7 points, let's say 80. Are you getting me right?
Yes.
The choice is yours. So what we are saying in essence is this, dear friends connected to this class. Once you get T1, use your discretion. Use your discretion. Decide likely what T2 and T3 should be. The values will be within the same range. Is that okay? Yeah. And with this, we can obtain T average. How can we get T average? Hold this for me here so that I'll be evaluating it for the friends to see. Make sure you complete the orders. But let me tell you guys something. If I were to be in the laboratory, having obtained these values, this is what I would do. If you check the difference between 5 and 5.27, is there about 0.27 or so? If you check the difference here, you would find out something unique. 5.27, let me press that. 5.27, you can follow up with your calculator. 5.27 minus 5. 5.27 minus 5 gives us 0.2 what? 7. Let us work on this. Let us work on this one. This next one rather. 7.67. 7.67 minus the one above. 5.27. That is there about 2.4. Then if you work on this one, 7.79 minus the one above, 7.67. you get 0. What? 1, 2.
2.
Are you following, right?
Yes.
Now, you notice that the value is not so uniform, the difference. Are you following, right?
Yes.
But if you take the average of the 3 differences you found so far, if you take the average of the 3 differences you found so far, one can conclude that the difference between the values you have can be approximately, let us say, 0.8, 1.0. Am I communicating?
Yes.
What do I mean by that? To get this particular one, I might decide to add 1 to this particular value. I might decide to add 0.8. So let me tell you guys something that are going to work on this experiment. Your T1 value, after the first 2 experiments, you can decide to start doing plus or minus. Okay, let us say plus rather. Can do plus 0.8 to 0.9. Okay, let me see, plus 0.8 to 1.0 to plus 1.0. Now this is the implication. Pay good attention to this. To get the next value for T1, you can add either 0.8 to the one above, or you add what? 1.0 to the one above. To get the next one, you add 0.8 or 1.0. If you're doing that, your experiment will still be within accuracy. Remember, this thing I'm telling you is if you do not have enough time. If you do not have what? Enough time. If you even look at the performance of the first experiment, you will notice that the values were more around 4. Is that not so?
Yes.
They were more around 4 because that first time that you did not place any mass, the oscillation was very, very what? Fast. So that the time will be what? Small. Is that not so?
Yes.
Okay, let us now evaluate T average. Let us evaluate T average. To get T average, what you have to do is to add T1, T2, T3 and divide by what? 3. So take your hand backward. Let me work on it. T1, 5 plus T2, 4. Okay, we have 5 plus 4 plus 4.50. I am dividing this by 3. This gives us what? 4.50. So T average here will be 4.50. Now come to average uncertainty. Don't mind me. This space is supposed to contain the value for this, right? Average uncertainty for the first guy. Look at the formula. 0.01 divided by T1 plus 0.01 divided by T2 plus 0.01 divided by what? T3. Whatever you get, you multiply by what? T average. So let us do that and see. Are we ready?
Yes.
0.01. Let's say it. I hope you can say this. Divided by T1. What is T1 value for the first experiment?
5.
Whatever you get, let me turn this so that I can use brackets. Whatever you get, you add it to another 0.01, but open a bracket this time to evaluate this. Are you following, right?
Yes.
0.01, you divide by what? T2. What's the value of T2? 4. Close your bracket. To evaluate the next one, plus. If you want to press all of them once, you use brackets effectively. Are you getting me?
Yes.
0.01, you divide by what?
T3.
Please, for this next one, we should open a bracket. We are trying to evaluate this. 0.01, then divide by T3. What's the value of T3 here?
4.50.
4.50, which is the same as 4.5. Now, this is what you get here. That bracket is going to give us 0.0067. Are you following, right?
Yes.
We shall multiply by T average. What is T average? 4.5. So I'm multiplying this by 4.5. This gave us what? 0.03025. You are meant to pick 4 decimals. Anything you're evaluating with calculator, you use 4 decimals. Are you following?
Yes.
Even this 4.5, you can make it 4.5000. So for our uncertainty for the first experiment, the value is 0.03025. Approximately 0.0303. Is that not so?
Yes.
So take note, please. This guy for the first experiment is 0. Permit me, I don't know where I'm going to write this because this This formula has covered that space. Let me squeeze it here. 0.0303. You can see it yourself. Okay? 0.3 approximately 3 from 5. You approximated this. Now, to obtain T average, to obtain period, rather, it's going to be T average divided by what? 10. What is our T average for the first experiment?
4.5.
4.5. Yes. We are dividing it by what?
10.
10. In fact, in the instruction, let's check so that you observe from the table of value. Generally, you know that period is defined as the time taken to cover a particular number of what? Oscillations. In the table of value provided, I don't know if this can appear. Let's see if it can show. Look at the column. Look at the column. So to get the period, it is T average. Let me bring it close. Period is T average divided by number of oscillation, which is 10. So hold it. Make sure you hold it this way because I want it to be showing. Let us evaluate it. Take it backward a bit. Let's evaluate it. I'm trying to guide you guys on how to evaluate all these terms. So for our T average, it is going to be, for our period rather, it's going to be T average, which is 4.5 divided by 10. 4.5 over 10 will give us 0.45 anyway. 4.5 over 10. 0.45. So one has to record 0.45 here. And then to get square of period, shift your hand this way. Square of period means to square this guy. Are you following right? Yes. So it's going to be 0.45 raised to power 2. So you are squaring raised to power 2, which is the same as 0.45 times 0.45. And this gives us 0.2025. 0.2025. Then we come over to this. How do I evaluate this young modulus? Look at these plenty things. That's what makes up the formula. So we are going to evaluate it. The young modulus is 16 times pi squared. So 16 times pi. This is my pi key. I'm going to square that pi. Okay, let me do it as 16 times pi times another pi. You see that, right? Yes. Because that's the meaning of pi squared. Times the value of the mass. For the first guy, there is no mass. So we are fixing 0 there. Times 0. I'll go again. 16 times 16. Oh no, 16 times pi times another pi. Then times 0. I'm wasting time for this. This guy is 0 because the mass there is what? 0. I'm wasting time here, please. But let me still show it. Everything here is going to be 0 because of that mass. Yes. So times 0. And then times, what do we have here? L. That L is the length. That L is the length of depression. Are you following right? Yes. And the length of depression is what? 15. Is the length of depression. If they give you any other length, you use it. Is the length of depression. So if you fix that 15 is in centimeter. And we are solving in SI units. So we shall be using meter. To convert 15 centimeter to meter, what do we do? Divide the 15 by 100. 15 divided by 100 will give you what? 0.5. So this is going to be 0.5 or 0.15 rather. So 0.15. Are you following right? Everything will be divided by our BDQ. What is our B? What is our D? From the instruction, the value of B and D are given to us. I'm going to show it. I'm going to write it out for you in the instruction. I have the instruction here. I'm going to bring out the value of B and D. Like I said, all of these are provided for you already. B is 2.57 centimeter and D is 0.56 centimeter. Let me indicate it here, please. Let me write it out. B is equal to 2.57 cm and 2.57 centimeter is equal to 0.025 meter. And then we now have our D. our D is equal to 0.56 centimeter. If you divide 0.560 m by 100, you should be getting 0.056 meter. Like I said, all these values are given to you already in your manual, so you don't have any stress in that. Okay. So hold it again as I evaluate that. Now our B, you can see it in meter. Look at it, 0.025. Then D, 0.056 in meter. I am solving in meter. We have evaluated up to this L, and I'm going to divide this whole term. I'm going to divide it by BDQ. Our B is 0.025. So 0.025 times D cube. Please adjust your hand this way. D cube. The value of D is 0.056 and it is cubed, so it's meant to be raised to power 3. 0.056 and then raised to the power of what? 3. We are now multiplying it by T squared. And we have the value of T squared from here already. Are you getting me right? 0.2025. 0.2002 what? 5. So we are fixing all these values and you see we got what? 0. That is expected for the first guy because the mass there is what? 0. Is that okay? Yes. The mass there is 0. This is what you repeat for the next guys to evaluate their values. Are you following, right? Yes. You come here, T average is going to be the summation of this divided by what? 3. Work on the uncertainty. Work on this, and get a value for this guy. On this experiment, I will tag it as part 2 of this experiment, where I will bring the complete table and possibly the follow-up questions, what you are asked to do. Tomorrow, hopefully, I've actually taught that very well on this channel, plotting of graph. So if I bring out a table of value, plotting of graph is a work that you have to do, but I am going to solve the whole follow-up questions. For example, there is one of the questions you are expected to evaluate your K. You are expected to evaluate K. K equal to 4 pi divided by slope. After you plot your graph, you evaluate the slope. Then you evaluate 4 times square of pi divided by the value of slope. Then you also have to solve for K using the formula F equal to Kx, that is Hooke's law. Make a subject of formula is going to be F divided by X and compare it with something. Much later tonight, you are going to see a work on it. Right? What I did here is to demonstrate this experiment for you so that you get to know how to carry it out. You are meant to load this mass until you get up to 300 grams, which is 0.3. That's the last mass. We have worked up to 150. Is that not so? That is half of it. It's sufficient. With this information, you can complete the remaining in your laboratory work. So I'll be seeing you guys later, like I said, where I would answer the follow-up question, also showing you the full table of value. That is going to come as a pre-recorded video, no longer live. I wish you guys the best. Bye. If you're here to subscribe to this channel, please subscribe right away, turn on your notification bell so that whenever I come on live, you will be the first person to be notified. Or if I upload any content, you will be notified. Share these lessons to your friend, okay? So that they can also benefit.